More factoring, yay. If you started doing the other factoring section, you realize that factoring really is the F word in math. It is a lot to remember and a lot to practice, and it's still sometimes hard to do. Hopefully common factoring, the one from the previous video, is not that difficult. That might be something like, so the instruction would be to factor 4x minus 8y plus 12z. You realize that each one of these is divisible by 4 and that you can pull that out. And so you have 4 and a bracket, and you're left with x minus 2y plus 3z. And this was called common factoring. And it's called common factoring because you notice what each of the terms have in common, and you yank it out to the front, but you still keep the same number of terms. The thing still has the same overall shape. You just pulled out something that they have in common. The next lesson has the uncool sounding title of Factoring Trinomials of the form x squared plus bx plus c. And sure. And this kind of factoring came out of someone doing lots of distributive property questions and realized that you could do the opposite. You could undo, and after you've distributed, you could pull out. So this common factoring is known by the common phrase of pulling out. Okay. This next kind of factoring comes from people having done lots of multiplying binomial questions. So things like x plus 5, x minus 4. And just to refresh your memory, distributive property in 4 steps. So that's 1, x squared. That would be 2 plus, no, squared. So x times minus 4 minus 4x, sorry. The third one would be plus 5x. And the last one, get the right color, 5 times minus 4 minus 20. So every time you do this, you have 4 of these little arrows. That gives you 4 terms. You always notice that the middle 2 terms are like terms, and you can put them together. Minus 4 plus 5 is plus 1x minus 20. And so anytime you do something that looks like this, with an x a number, an x a number, 2 binomials, you always get something that has this shape, a trinomial, and it always has the same shape, an x squared, a number, an x, and a number. That's what this is. X squared plus a number x plus a number. And the way you factor is very counterintuitive. It's an algorithm. And all that means is somebody was cleverer than both of us, and there is a set of steps that works, and people find it frustrating because it's not exactly a short set of steps, but it always works. So you have a toss-up. You can either sort of stare at this, at factoring questions and try and guess. Let's actually look at a question. So my job is very, very simple, is to guess what this would have looked like before somebody did the distributive property on it. That's it. And you could stare at this and you could try and guess, and it's actually possible to get into the knack of it and get into the habit, and it's not entirely difficult, but there is a system that always works, and so that's what we're going to work on, and we're just going to work through examples, and the steps will always be the same. So the first thing I do is look at the last number, which in this case is 4, And now I have to make the complete list of the ways to make 4 by multiplication. And in 4, it's actually fairly short, but I'll show you how to write them in order so you can always be sure you haven't missed any one. Always start with 1. 1 times what is equal to 4? Well, the answer is 4. Now try 2. 2 times what is equal to 4? 2. Now, you read this in a kind of a horseshoe, start at the top and go back up, and as soon as you get to a number that you've already written, that means you're done. Now, we knew we were done. The list for 4 is not that long, but it means that I do not have to check the number 3. Because I've gone in order, 1, then 2, and the number 2 has already appeared, I don't have to check any more numbers. All right, the next piece is to look at these 2 combinations, and I need to now look at the middle number, which is 5. And I have to find a way to put one of these pairs together to make 5. Now, 2 and 2, you can add 2 and 2, that makes 4. You can subtract 2 and 2, that makes 0. These do not make 5, but 1 and 4, 1 plus 4, or positive 1, positive 4, is equal to 5. And this is what now goes here. By the way, we always know that the first number is an x. That was not a mystery. Plus 1, plus 4. And that's the answer. So this has now been factored. By the way, if you weren't sure if you were right, give this question to somebody who was just learning the distributive property and see what they do. X times x, x squared, x times 4 plus 4x, 1 times x plus x, 1 times 4 plus 4, 2 like terms in the middle, x squared plus 4 plus 1 is 5x plus 4, and you get back the same thing, so you know that this was right. Okay? And we're just going to apply the algorithm over and over and over again. And what makes this take time is this last number. So the list for 12 actually does get a little bit longer. Always start with 1. 1 times 12, 2 times 6, 3 times 4, 4, no, I've already written the number 4. That means I'm done. And now you can see that by going in order, you've saved yourself a lot of time. I do not have to check 5, 6 is already there. I don't have to check 7, 8, 9, 10, or 11, or 12, because they're already written down. And now I need to look for a combination that goes together to make -7. So putting a 1 and a 12 together, you can get 12, you can get 13, which means you can also get you can get 11, you can get 13, so -11, -13, not that one. 2 and 6 will make 4 or 8, no. 3 and 4. -3 minus 4 makes -7. So that means x minus 3 minus 4. Again, you're still not trusting this random series of steps to see that it works, so let's just double check to make sure. This would be x squared minus 4x minus 3x plus 12, 2 like terms in the middle. And yes. So this step, by the way, is completely unnecessary. So if you remember the algorithm and you follow the steps in the right order, there is no need to actually write this. What it does is it gives you a little bit of peace of mind so that if you're doing a test or a quiz and you're not sure if you have the right answer, then you can actually check and see whether or not you do. So let's see how many more examples we can just get through, and we'll start to go a little bit faster. So here, this next one, x squared plus 5x minus 24. Look at the last number, 24, and make the list. And again, the list can get quite long. 1 times 24, 2 times 12, 3 times 8, 4 times 6, 5 does not go into 24. 6, I've already written the number 6, so I am done. And this is the piece that everybody finds annoying. And he says, shouldn't there be a faster way to do it? There is no faster way to do it. The only thing I can say to you is if you do enough of these, so you start doing 30 of them, 40 of them, 50 of them, 60 of them, you start to get into the habit of, well, I've written, I wrote out this entire list for 24 3 times already today, so I'm pretty sure I know what they all are. But nothing really beats just having your times tables memorized. Can I put a 1 and a 24 together to make plus 5? The answer is no. Can I put 2 and 12 together? No. Can I put 3 and 8 together? Yes. Plus 8 minus 3 equals positive 5. It's also worth double checking the last one. Can I put a 4 and a 6 together to make 5? The answer is no. And generally there's only one that works and you don't have anything to worry about. And the answer is just then 1x here, 1x here. Take the two numbers, positive 8, negative 3, and that's there. And you're going to take my word for it, but if you don't, you can go back and you can distribute and you can check. But we're going to say that's the right answer, and if it's not, say something in the comments. This one here, this one is one of the few confusing ones. So if I look at the last number 6, I go over to the side and I write the list for 6. That is 1 times 6 and 2 times 3. This, by the way, is exactly how I write it when I'm doing my homework or helping someone else with their homework. My answer is going to go directly underneath the question, but this sort of mechanical boring part I put off to the side. And so this space, this entire half of my page is left more or less empty for the times that I need it. I'm not going to try and answer. So if this was question 1, I would not try and put the answer to question 2 down here. I would put the answer to question 2 underneath like that. Anyway, back to these. This is now a problem because 1 and 6, yes. Plus 1 minus 6. That is equal to minus 5. But also, minus 2 and minus 3 are equal to minus 5. That's a problem, and you have to find a way to tell the difference. So let's get rid of that. And this is what you do. You imagine what the answer looks like, and you think of the arrows. So this arrow produces the first number. This arrow and this arrow add together to produce the second number, and this arrow produces the 6. And that's a positive 6. It means that the two numbers here that I choose must have the same sign. The way I get a positive number is positive times positive or negative times negative. So I have to choose the answer over here. I have to choose the one where both of the numbers have the same sign. So the answer to this will be x minus 2, x minus 3. And I won't do the check. If you don't believe me, pause the video and put the arrows back in for yourself and see that this is in fact what you get. I'll leave that there so it is a little tidier. Okay. Keeping going with more examples. If you've got the hang of this and you want to start working on your homework, by all means, but let's just do a couple more. So this one here, I look at the number 8, and the list for 8 is not that long. It is 1 times 8 and 2 times 4. 3, no, 4 is already there, so that's it, that's done. And can I put a 1 and an 8 together to make 4? No. Can I put 2 and 4 together? 4 plus 2 is 6, 4 minus 2 is 2. So neither one of these work. When you have gone to all this trouble, and when you've checked them all and none of them work, what that means is this question is not possible to answer. So some things just don't factor. And the analogy is something, a prime number like the number 7. You cannot find two numbers to multiply together to make it except 1 and 7. There's just no way to find things to go in here that will have this work. It can't be done, so you don't write any of this. And once you have shown this, this is your work, and your answer to this is DNF, and DNF is short for does not factor. So that is how you know that something doesn't factor, is if you've made the list and there's nothing that works. And there are a handful of those questions. So even on a test, if you are asked something like 5 to 10 of these questions, do not be surprised if one of them comes back with the correct answer being DNF. Okay? Now, this one is the last one that we'll do, and strictly speaking, this doesn't work because this is not of the form x squared plus bx plus c. It has the wrong exponents. There's an x there, the numbers are wrong, there's a number there. So there's all sort of things about this that don't work. There's a way around that, however, which is you do remember common factoring. And there are questions that contain multiple kinds of factoring in them. So if I look to these three, all of those numbers are divisible by 2. That means I can have a bracket with a 2 in front of it. Also, all of these contain an x. So I can take 1x. I can also take this minus 2, and I'm going to have to do that if this is going to work. So this will be x squared. I have pulled out this minus, so it's here. So all of these signs change. There, and this will be minus 24. Let's just tidy that up like this. And now the 2x will sit in front, and this will turn into 2 brackets like this, and you make the list for 24. Now in this case, I don't actually have to do anything, because if I flip back over here, that is this question over again. So x plus 8, x minus 3. I save myself some trouble. And also, don't be caught too off guard if that happens on a test where they actually give you an opportunity to have 2 questions that are very, very similar, and you can do a long, boring bit of work, but then 2 questions later, they just let you use the same boring bit of work over and over again, and you're not allowed to copy off your neighbor, but you're allowed to copy off of your work from 3.5 inches up the page. So that is that kind of factoring. Coming up next is the very scary kind of factoring, and that is ax squared plus bx plus c. And if you put a number there, you'll see that makes things insanely difficult. So good luck practicing with that. If you have any questions, leave them in the comments, and we'll get to some new stuff very soon. Thanks.